We created the IEEE Low Power Computer Vision Challenge because we wanted to encourage innovations in efficient artificial intelligence. Computer vision is this technology that allows computer programs to understand images and videos. And lots of applications need efficient computer vision because those systems run on batteries. So for example, if you're using your phone to take photos or videos, it would be great if your phone could run computer vision tasks, say recognizing your friends in a photo or understanding your videos. But that computer vision needs to stay efficient and not drain the battery too quickly.
The Low Power Computer Vision Challenge started in 2015 at the Design Automation Conference. Tsinghua University took first place in 2015. Then, in 2017, the challenge moved to the International Conference on Computer Vision and Pattern Recognition. Teams come from all over the world to compete, representing the United States, Canada, South Korea, China, Taiwan, and Russia. Winners were an equally diverse mix of universities and companies, including Amazon, ByteDance, Baidu, Qualcomm, MIT, Seoul National University, and the Chinese Academy of Science.
Low-power computer vision is very crucial for mobile AI, but it's very challenging due to the high demand of computational resource and also human resource to tune the models for different mobile platforms that are power constrained. We propose the once-for-all network and AutoML approach that can reduce the computation, memory, and human efforts, automatically designing small and compact models for diverse mobile platforms. It won 3 rounds of low-power computer vision challenges hosted at ICCV, NeurIPS, and CVPR, including the CPU track, DSP track, and also the FPGA track. We thank IEEE, Purdue University, Xilinx, and Google for organizing the computation. We have open-sourced the once-for-all network at ofa.mit.edu. We encourage everyone to participate in the computation.
Since 2018, contestants can submit their solutions online. In 2019, this became an online-only challenge, and in 2020, 46 teams submitted 378 solutions in 4 tracks over the 1-month competition. Each solution is evaluated by the accuracy as well as the energy consumption.
Here's how the competition works. A participating team submits their solution online, then the solution is validated. Finally, the solution is sent to an automated referee system. The system evaluates the accuracy, measures the execution time, and the energy consumption. The final score is the accuracy divided by the energy. To win the challenge, a solution has to be accurate and consume less energy.
Reproducibility is an essential component of the challenge. This challenge is different than just publishing a typical paper. Winners' solutions have to be open-sourced and validated for reproducibility.
Our winners' solutions have been presented in many conferences, including the International Conference on Computer Vision and Pattern Recognition, IEEE's International Conference on Artificial Intelligence Circuits and Systems, the Design, Automation, and Test Conference in Europe, and the International Conference on Computer Vision.
Since 2015, IEEE Rebooting Computing provides administrative and financial support. The challenge has received generous support from many sponsors, including NVIDIA, Google, Facebook, PyTorch, MediaTek, Xilinx, Eland Microelectronics, National Science Foundation, and multiple societies in IEEE.
Since 2020, a new track has been added for processing drone video. The problem is to recognize English letters and numbers in the video taken by the drone. Future challenges may include more complex problems, like tracking multiple moving objects when people play soccer.
Low-power computer vision is important for many scenarios beyond drones. The list goes on. Low-power computer vision can be used in many other places, such as wearable cameras, or cameras powered by renewable energy for wildlife observation.
We look forward to making computer vision more energy efficient so that the technologies can be used in drones, edge devices, or the Internet of Things.